Hello everyone, I am Lishi. Let's continue looking at this number. First, let's look at the operand. It is a regular number. It can use standard negative quality constructors or negative quality operands for a negative quality operation. Because the number strictly possesses its elements, the negative quality number is generative negative quality, and then the new number will possess a copy of its own elements. In fact, we have completed a deep copy. Should be. So this place adds 3 elements. Then this place used auto to connect it. So actually, this type is just a number, because this directly copied the number over. So actually, if we want to change its value like this, then after changing it by copying, the value is such a result. So actually, we use the open function. Actually, we can also use the plus equals operator directly. It was directly connected, and it simultaneously supports movement semantics. It means that this number, I might need to move the elements inside to another side. Then, if I want to do it, how should I do it? First, I copy. After copying everything, clear my previous host again, right? So, at this point, you can directly use this. 波波的 wing device. You can completely transfer the memory over. It's roughly about that. Okay, let's look at these 3 first. So, back to our side. We use this. We call it... Actually, if we're talking about functions, if we should strictly follow this specification, we should use the verb, then the super longitudinal array for operating, right? Operation array. Okay, let's take a look at how this is written here. First, come over here. And actually, it is like this. It instantiated an array. It's just an A2J. So we can actually write it like this, a bit simpler. We A25. Actually, here, we can just write it like this. Just paste it here. After all, we are programmers. Use these counter and VC more. This isn't saying, why do they say you should use counter plus V more often? This isn't saying it's not a good habit. This is a very good habit, because when you write code, you're very likely to write things like this. For example, I am an A-I-R-A, and you are very likely to write these R's, or rather AAR. You still can't find it after all this time. So counter plus V's, so we'll just directly apply it. This is a quite convenient operation. Then, this area demonstrates these 2 hosts. The operation we performed today, it became 5. No problem, we can verify it later. Then let's look at the next one. The next one is host chaining and movement semantic. How did we link them before? For example, let's say we have a new number now. We give it a new number. We give it an area of 6. And now it is empty. But for the empty one, we can set it equal to arrays. Then we connect 1 through it. We can use appends. Then you will find that we can pass this here. We take this per se and spread it in. This is the best code. In this place, it gives a source, that is, add the digits to the tail end of this number. And then, so this optimal operation, we can simply finish it. Next is the movement semantics. If I want to move one host to another host's location, right? And note this spot. As you can see, after it has finished moving, the original host is actually added over. No, that's not it. It seems like it should cover. It should have covered. It's equivalent to this oracle in covering. We can verify it. Let's give an oracle 7. And then we make it equal to una o eno. Then we'll move this AV6 over. We use this movement semantics. Okay. Okay, let's execute it now. There shouldn't be any problem. Let's launch it. this area should be operational. Okay, let's see if there are any breakpoints. If there are break, we just launch it. Okay, so we created a host named 1223 here, right? And this place is a UTU4. Yeah. We see that this UTU4 is a host. It is also 123, and this OU5U Balafole is actually also 103. Then we change the first digit of 45. So now 4 becomes 5, 2, 3. So as an RA6, we first add an RA4 into it. So we become SA5 often 2 half RD2. Then we add an RA3. The idea is to append 123, so it becomes 52231233. No problem. Then we now have an RD7 nearby. In the case of R7, we move RE6 into RE7. We found that RE6 becomes 523123. The original number was essentially overwritten. Okay, so this place demonstrates for everyone. If it is a structure, it's actually pretty similar, but structures involving the construction and release of structures might need to be a bit more complicated. But the overall concept is like this. Let's set up a point first. We'll look down, and then in this area, between numbers, besides the equal sign, we can also use double equal signs and not equals signs to compare using this method. Note that the matter order of the array, the sequence and quantity, must be identical. Only then will they be considered equal. Then the element itself must have a definition. This operator, how you consider two elements are equal. Then you can take this step. So in this place, declare the real number array. And then separately, through a plus, in this manner, adding 2 characters won't be counted. And also copied a second array. So now we compare these two arrays. They must be exactly the same. And then we first convert it to uppercase. And then we compare them at the same time. Then you will find they are still the same because our comparison is case-insensitive, F data. So we can make it case-sensitive here, and this place is X. Where did this function come from? I haven't seen this function. It might be self-written. The spot might have been slightly changed, and it's equivalent to flipping the front and back data. You'll notice that it's different. So let's implement it for everyone. So it's very clear. It's still the same old procedure. We will give this spot an str. Okay, let's go back here. We'll make some slight modifications and expansions to this example. Move over here. All of these previous parts are completely fine. This spot, it should be this number. It should be 高倍. Complete a 高倍 operation. It should be basically the same as our log. But if we need to add something, we can add this. Let's add this. This seems difficult to implement. Then we won't add it. I actually wanted to tell you something. When this string performs a comparison, you should be able to enable case sensitivity. I just wanted to bring this up with you. This exchange actually has this function. You'll notice that this exchange, it's used within the Unreal Engine template. It actually uses this stripe. This stripe should also be a template. You can see it's a template for swapping like this. It used this small temp. It's equivalent to swapping the memory of two things. It just swapped them directly. That's what I mean. Okay, so let's take a simple look at this function. Okay, so let's execute it. We'll execute it here. The function node here is called execopate. It looks like we removed this node before. We can drag it out. Yep, that's fine. Then we will start executing it here. Okay, it came in. This spot generates a calculated output. Okay, there are no issues with that either. Next, let's move down. A copy was completed in this spot. No problem. This comparison should definitely work because you are also a copy. And then this place performs a major, and then you will find that the comparison here is still correct because it ignores this bridge write sensitivity. In this double ampersand operator, we perform an exchange here. We swap the element of the second host, and at this point, it becomes false. Okay, so this simple operator validation, we'll stop here. Next, we will look at the content that follows.